say 2A plus 3B equilibrium. Let's say 4C. Lechateliers system, Lechateliers principle says, when a system is at equilibrium and you disturb it, what happens?
Compensate.
Try to fight the change.
The word is counteracts the disturbance. That's what you need to remember. So it counteracts the disturbance. Counteract means exactly the opposite what you have done to it. Okay? So let's say that the concentration of A is increased. This is a shorthand, okay? It will be in words on the test. But this is shorthand, so we don't have to say that. This means concentration, this is pressure, but it doesn't matter. It's the amount of A that increases. Where does the reaction go? Does it go forward or reverse?
Forward.
The reaction goes forward. Why does the reaction go forward? What does the system try to do to an increasing amount of A? It tries to decrease it. The only way to decrease it is by going forward. Because if you go forward, this gets used up and that gets used up. And what happens to this?
Get more of that.
This gets made, yes, let's say. The concentration of this increases. So let's say I had here 1.0 ATMs, and here I had 0.7 ATMs, and here I had 0.5 ATMs. If I add A, what happens to, of course, I'm changing the pressure of A, yes? So I don't talk about this, right? But it was 1, and I added some. God knows what it is now, but it doesn't matter. What's going to happen to this pressure? Hello?
Yeah, concentration will increase pressure.
It's going to decrease, yes, because the reaction is going to go forward. And this pressure is going to decrease from this number. It doesn't matter to what it's going to decrease, but it's going to decrease. And what is going to happen to this pressure? It's going to increase above that number. This is going to decrease above this number. And we don't talk about this number because we are changing its value. Yes? Let's say the concentration of B goes down. What happens?
Go backwards.
The reaction goes in reverse because now you need to do what? Make more B. Yes? And the only way to make more B is by going reverse. What's going to happen to this pressure if it goes reverse? It's going to decrease. This is the one we are changing, so we don't really know what it is. What's going to happen to this pressure?
Increase.
It's going to increase above this number.
Yeah.
Yes? Above 1.0 ATMs. How's that?
Good.
It's cake, yes? What happens if the concentration of C goes down? The reaction goes forward.
Yeah.
The reaction goes forward. Why does the reaction go forward?
To make more sense.
To make more C. Okay? It needs to make more C, so we don't talk about this number. What's going to happen to these two numbers? It's going to decrease from both of them. Okay? Yes? That's changes in concentration. Another change that you can have is a change in pressure. Let's say the pressure goes up. Write this down. If the pressure increases,
Concentration decreases.
if the pressure increases, the reaction goes to the side with less gas molecules. So if the pressure increases, what does the reaction try to do to that pressure? Hello?
Say it again.
You still writing that? If the pressure increases, the reaction goes to the side with less gas molecules.
So here we go towards C, we go forward.
We don't know. We're going to do that right now. If the pressure increases, what does the reaction try to do? to the pressure.
It goes,
Decrease it. If you increase it, the reaction is going to try to do what to the pressure? Decrease it.
mm-hmm,
Now, the more gas molecules you have, the higher the pressure. And the less gas molecules you have, the lower the pressure. So if you increase the pressure, the reaction will try to lower the pressure by going to the side with less gas molecules. And you gotta count the number of gas molecules. How many gas molecules do I have on this side? I have 2 and 3. So this is 5 gas molecules, and this side has
or,
4 gas molecules. So if I increase the pressure, the reaction is gonna go towards the side with less gas molecules, so the pressure is lower. Which side is that?
Forward.
This is the right-hand side, so the reaction goes forward. Does that happen all the time? That the reaction goes forward when you change the pressure, when you increase the pressure? No.
depends on how many molecules.
It depends on how many molecules. But I may do only one type of problem here, and you guys think, oh, it always does it the same way. So I'm gonna write on the test, it goes forward. It does not. Volume has to be converted to a pressure change. So let's say I increase the volume, what happens to the pressure? So you cannot do volume. You gotta change it to pressure.
Mhm.
What happens to pressure as volume goes up?
It goes down.
Decreases.
Pressure goes down. So I write in little here, so you know that this is not what was given to you as the problem. The problem is volume increases, the pressure goes down. If the pressure goes down, the reaction goes to what side?
The one with the less gas molecules.
If pressure goes up, reaction goes to the side with less gas molecules. If the pressure goes down, reaction goes to the side with more gas
So it's
molecules.
gonna go to the left.
So what side is it? To the right?
Back to the.
It is to the left because the left has how many gas molecules?
5.
5 gas molecules, so this side will give you higher pressure. So the reaction will go to the left. Questions about this, my friends?
Temperature.
Yeah, but questions about this? We're missing temperature.
Yeah, why is B decreased in the first one when A increases?
When what?
Why is B decreased in the first one when A increases?
What do you mean, why is B decreased?
Well, there's differences.
You mean as written on the board?
Yeah.
No, this is not what happens altogether.
No.
This is one thing,
Right.
this is another thing.
Just the first one. Just A.
A,
When A increases, why does B decrease?
when you increase A, where's the reaction going to go?
Okay, right?
It's going to go forward, and if it goes forward, what happens to that amount? It decreases because it's going forward. Okay. What else? Temperature. In order to determine what happens to temperature changes, you need to know if the reaction is exothermic or endothermic. So in order to determine this, I have to give you whether the reaction is exothermic or endothermic. Is this one exothermic or endothermic? What's this one? Exothermic or endothermic? You cannot tell. I gotta give you delta H. Delta H for this reaction is, let's say is minus 75 kilojoules per mole. Endothermic or exothermic?
Exothermic.
Exothermic because of this negative sign, so this is exothermic. So, if the reaction is exothermic, is heat a reactant or a product? Ms. Rodriguez, as you learned in 1045 from your instructor, is heat a reactant or a product? How do you know? That's right, you're right. So how do you know? You just guessed? Guessing is allowed. Well, if the reaction is exothermic, that means that heat was released, yes? Your released money, is it yours?
No.
What do you think?
To other people's.
Now, whatever you release is no longer where it was before, yes?
Mhm.
So if it is exothermic, it is on this side, okay? If it is exothermic, it is a product. If it is endothermic, heat is a reactant. You should have learned that in 1045 when we did those equations. Okay? So heat is a product here. And if it were endothermic, heat would be a reactant. And you have to write it, okay? So this is exothermic, I am going to write heat as a delta. So if reaction is exothermic, place a delta. And delta means heat, okay? Delta means change, it also means heat. Place a delta on the product side. If it is endothermic, where are you going to place that delta? On the reactant side. This one is exothermic. I'm going to place a delta on what side?
Product.
On the product side. Look here. Plus delta. Because heat was produced. Yes or no?
Okay.
Then you are going to treat that delta as if it were a product. So treat delta as if it, because it is a product, yes? So if the temperature goes up, delta goes where? No, don't tell me where the reaction goes. If T goes up, delta goes up. Yes or no?
Yeah.
You're going to treat the T as if it were that delta. So if T goes up, the delta goes up. If delta goes up, where does the reaction go?
Left.
Reverse.
It goes reverse, because it needs to decrease this, yes? The only way to decrease it is by using
Using
it,
it up.
by going forward. Yes or no?
Mm-hmm.
Some of you don't seem very convinced. Hello? Violetta, you have any questions? You understand it? Don't lie. I'm gonna ask you a question right now. Only lie to your boyfriend, not to me. The reaction goes reverse. If T goes up, what happens to the delta? Does it go up or down? It goes up, because the T and the delta is the same thing.
Mm-hmm.
So if the T goes up, reaction goes away from whatever you increased. So it's gonna go reverse. Yes or no?
Yep.
Let's do one last one and we'll kill this one forever. I am never going to do another one. Ever. The amount of B went down. Where does the reaction go? Finish writing it. Finish writing it.
To the left.
We're gonna have such a long lab today,
Really?
so be there on time. If you're not there, I'm gonna not let you in today. Okay? Is that clear? So if the amount of B goes down, where does the reaction go?
Reverse.
To the side that
Where it went
makes
down.
B. That's reverse. Guys, anybody has a problem with this? Raise your hand if you want me to say this again. No? You sure? If I were to give you a quiz right now, you are not lying to me, right? Because you only lie to who? To your boyfriend, yeah? Only lie to your boyfriend, not to me.
Professor, do solids count?
The what?
Do solids count?
Don't mess it up, man.
That's the whole catch.
And I've been saying this already for 20 times I've said that, right?
Solids and liquids.
Damn, always gotta be somebody jinxing it for you, man. Messed up. Are you a Miami Heat fan?
No.
Oh, okay. Alright, so what happens if the amount of C goes up?
Go a little bit reverse to the left.
The reaction goes where?
Back, reverse.
Okay. If you increase the concentration of C, the reaction tries to go away from it, or tries to decrease C, and the only way is to go reverse.
Yep.
Very good. I want you to do these now. I want you to say pressure, let's say pressure went down, volume went down, temperature went down.
Do you have to be specific on like what pressure goes down, like pressure of A? Or
No, this, yeah. That's why I'm writing concentration for A and for C. So
Okay.
you don't confuse with the pressure. This is overall pressure of the system.
Okay.
So this is not the pressure of any of them, this is the pressure of everybody. What a sleepy day, huh? Sleepy outside. So, forward or reverse for pressure?
Forward.
Huh?
Reverse. Reverse.
Okay, so if the pressure goes down, the reaction goes to the side with more gas molecules, yes? This side has 5, does it not?
No.
Oh damn, the solid. Oh.
Yeah, that's why he almost messed that up for some of you. This is a solid, it's not a gas. Unless you thought this was a G, yes? But if you thought this was a G, you're blind because that's a G. But they're not the same. Okay? And that's another, actually, you know, 3 different types of G's, yes? Alright, so this is a solid. So, because it's a solid, it's not a gas.
Alright.
How many gases are here? 2. And here? 3 gas molecules. So if the pressure goes down, the reaction goes to the side with more gas molecules, which is?
Forward.
Forward, because we counted them. How do you like that? That's a good trick question, yes?
Mm-hmm.
What do you call a trick question?
Trick question.
How is a question tricky? Explain this to me. Because it's not tricky to me.
You purposely add a bunch of random numbers or complicated numbers when you can just give ones.
That's trick.
Anything besides
I
ones.
think a trick is when you put little details that you
So
have
on
to
the
pay attention
test,
to.
give everything ones.
Trick questions don't exist, my friends, okay? You only get tricked if you don't know, right? Right? Yes or no? That's what it is. You only get tricked if you don't know. I mean, yeah, if I write too many numbers or little details like you're saying, that's making you read them and confused about them. But you still, if you know, you don't get it wrong. Volume goes down, what happens to the pressure?
Goes up.
Goes up. If the pressure goes up, reaction goes to the side with
With less.
less gas molecules. That happens
on the
to be the left-hand side, so the reaction
Yeah.
goes reverse.
Yeah.
You messed it up, man.
Yeah, right,
It's not only the calculator. So, if the temperature goes down, what do I do?
You look at the.
Forward, it goes forward?
No, okay.
It depends on the endothermic or exothermic.
You have to look at delta H. This is exothermic or endothermic?
Endothermic.
Endothermic. If it is endothermic, I'm going to place a delta where?
On the reactant
The
side.
reactant side. I'm gonna come here, and I'm going to place a delta here, which is acting like what? A reactant or a product?
Reactant.
It's a reactant, and you just treat it as if it were A or B. Temperature goes down. If the temperature goes down, what happens to this delta?
It goes
It
down.
goes down as well, yes? And if this goes down, the reaction tries to go what side?
To the left.
Reverse.
It tries to go to reverse because it wants to increase this. So if the delta goes down, the reaction goes to the left. Yes or no?
Clear. Yep.
I am going to give you 6 of these questions on the test.
Perfect.
I'm not tricking you. I'm gonna give you 6. That's the hardest of them all.
Really?
Yeah. How are they gonna get harder than this?
Oh.
Now, if I give you pressures, or if I give you concentrations, then you have to know whether they go up or down, yes? You never look at the one you are changing, but the rest of them change whether you're going forward or reverse, yes? We did those at the beginning. You guys want to test? What day is today, Monday?
Tuesday.
Very good. Test next week, yes?
Let's go.
Thursday of next week, my friends.
Go.
A little test for your enjoyment. You want a quiz on Tuesday?
No. Monday. No, it's good.
Thursday's good. And then, how many chapters do we have after the next test?
2 chapters. Always 2 chapters.
And then the final.
Yeah, the final is gonna be very juicy.
What does that mean? Like thick, like a lot of stuff in it?
Like all the stuff in it.
Yeah.
We did what is Q used for? What is Q, first of all? What is it?
It's like the
What's, no.
Is it a reaction?
Like KEQ is called equilibrium constant. What's Q called?
The reaction.
Reaction quotient. What's the expression for it?
It's like just the equilibrium constant, but without the equilibrium concentrations.
So, same expression as the equilibrium constant expression. You just don't know if it's at equilibrium or not. So what is Q used for? To determine if the reaction is going forward or reverse. To determine if the reaction is at equilibrium or not. Q has to be compared to what?
Okay.
To the equilibrium constant. Yes or no?
Yep.
Why are some of you trying not to make eye contact with me? I don't understand. Do I have something in my face? Or you're avoiding me looking into your soul?
Oh.
Alright, let's do another problem, okay, since you are enjoying this chapter. I thought kinetics should have been the one you enjoy the most. Equilibrium is awesome, because you can use it for drugs, yes?
Yes.
I did not say anything about drugs? What?
Give us an example of drugs.
No,
No. No. This is called the Haber process. Guys, what's the conversation? This is called the Haber process. This is for making ammonia. His father made this process. So, this ammonia is the #1 base used in the world, my friends. Okay? So making ammonia is a big deal. The guy that made this reaction work or came up with that process won the Nobel Prize. Okay, what's the difficulty here? Difficulty here is this, yes? Difficulty here is breaking the triple bond in nitrogen. Right? Is that difficult or easy?
It's very strong bond.
Yeah, you probably don't know, right? How much nitrogen do we have in the environment?
A lot.
How much?
Isn't it like mostly composed atmosphere or something?
Yes, it is. But how much?
70-something%.
It's about 80%.
Whoa.
79 something, 80%. So, is it 80% because it's very reactive, or is it 80% because the thing does not want to react with anything? Because it doesn't want to react, yes? There are not many organisms that can get nitrogen like that from the environment and make ammonia from it. What can do it? You guys taking microbiology?
Yeah. Little like little micro, like little arches, little micro.
The what? You said little microbes 20 times already. Where do they live?
In space.
No. There's no nitrogen in space, my friends.
That we know of.
No, we know what's in space and it's not nitrogen. There's no gas molecules in the outside, yes?
No, I'm thinking of. No, that's not it.
Yes, it is in the nodules of some plants, yes? And they are bacteria. Okay? And they are nitrogen-fixing bacteria. And they convert that nitrogen gas into ammonia, nitrates, and nitrites. Okay, so the plants eat it. And that gets introduced into organic components. Okay? Anyway, that's why that was a big deal, because only a couple of different organisms can do that.
So how does the reaction work?
Which reaction?
This Haber process.
What do you mean?
If it's hard to break it, then how do you break it?
Oh, a catalyst does it. All right. So let's say I have So the partial pressures were measured to be for H2, 0.928 atms, for N2, 0.432. And I want you to calculate the partial pressure of NH3 at equilibrium. Okay, I want you to try to do the problem without saying anything out loud or without asking questions, so you mess up other people's ideas.
0.432.
What happened?
Is that 3 on the?
Point, yeah, 0.432. Now you can talk to your friends if you want. Except for Miss Rodriguez here, because she has casual conversations all the time. So Ms. Rodriguez, what did you do on your birthday? Did your parents let you go out at night?
No, we went to dinner.
Yeah.
You have a curfew, don't you? I'd give you one if you were my daughter. 5 o'clock, 5 p.m. How do you know what?
compared to with the.
I gave you hints for you to know if it's at equilibrium or not. And the hint is measured there. They were measured to be. So they are at equilibrium.
It's all in the wording, huh?
Yeah. So guys, what the deal is here? Do we have to build an ice chart?
No.
No, we do.
These pressures of H2 and N2, when are they? At equilibrium, before equilibrium, or after equilibrium?
At equilibrium.
That is at equilibrium, and they are at equilibrium because I am telling you they were measured, yes? Of course, before you put anything anywhere, you still gotta measure it, yes? But most of the time, the wording measure will tell you that they happened after you mix them. So at equilibrium, those are those numbers. If I tell you that they are initial, most of the time, I introduce them into a flask or say the flask was charged. Guys, you're not paying attention? You're gonna watch the video. I don't know, this recording is getting to me already. I need to record other stuff.
Like what? We're gonna make some crazy stuff in the lab.
Like me skydiving. Guys, who wants to go skydiving with me? I'm coming up with a group. If you are interested, see me later. And I'll tell you.
Oh, I wish I could, but now I have this broken foot.
Yeah.
That's alright. You can still skydive and break the rest.
Pass out for sure.
You know how much it
On the
is?
way down, let's run the parachute. Out cold, right?
Well, you know, it's with another person. You're not gonna do it by yourself. Mine is gonna be a hot girl in case I die.
I'll ask Mitch how much he paid. Let's see.
Have you ever skydived?
You never skydived?
You skydived before? Is that like something everybody does?
Bro, that's a lot of things my friends do.
I heard you have to hold your breath.
No.
I don't think so.
Yeah, I swear to God.
Really?
Yeah, like that.
I don't know. We'll try it. Don't jinx it. I want to be surprised.
So down.
I want to be shocked.
Pass out.
Hopefully, I don't get a diarrhea in the air. All right. Okay, guys.
I feel bad for the girl that's gonna be behind you.
I feel bad for her too. I'm gonna start grabbing things because I'm really scared. All right. So the equilibrium constant. What's the equilibrium constant expression?
That one.
Miss Rodriguez. What did I just ask? Right. So the equilibrium constant expression is products divided by reactants. I'm going to say the pressure of the product, NH3 squared raised to the second power, divided by the pressure of N2, that is raised to the first power, and divided also by the pressure of H2 raised to the third power. Those numbers that were given to you were at equilibrium. Do we have the equilibrium constant?
Yes.
Yes, so we have this number. Do we have this number, the pressure of N2? Is that at equilibrium? Yes. Do we have this number? Yes, at equilibrium? Yes. The only number we're missing is this one at equilibrium. We have all the rest of the numbers. So yes, we are going to solve for this. Equilibrium constant multiplied by the pressure of N2 multiplied by the pressure of H2 raised to the third power. This is equal to the pressure of NH3 raised to the second power. I'm going to find the square root here and the square root there for the math specialist in the class. So I am going to write all of this. What's happening to my pens? You feel compelled to say that it's a marker and not a pen. Okay, my friends, let's see if I get this right. No. The pressure of H2. What's the pressure of H2? 0.928. I'm going to raise this to the third power. The pressure of N2, 0.432, times the equilibrium constant, which is 1.45 times 10 to the minus 5.
No units?
No units, right? The equilibrium constant does not have units.
No, you didn't put the units for the ATMs either.
What?
You didn't put the units for the pressures either, is that not required?
Because the unit doesn't have units by convention. It means that this unit here will be to the third power, yes? And this unit here will be, oh, this does have units, this is pressure, yes? But, yeah, this units will be to the third power, this unit will be to the, I don't know what power this will be, to the first power. And then the square root of the fourth power is
Squared.
square.
But ATM squared doesn't make a lot of sense.
That's right. So, do this calculation and tell me what this number is. Huh? 2 point,
Times 10 to the negative 4.
2.23 times 10 to the negative 3.
so 2.24 times 10 to the minus 3. What are we gonna do with the units for this?
It looks like
Should-
ATM squared.
Should we put them units inside? The equilibrium constant does not have units, yes? So that creates a problem. The reason why it doesn't have units is because it's raised to these powers, yes? So you cannot use a number in which you use this number and then the rest of them and expect this to solve for the correct unit. So you are going to sit. Whatever you calculate, whether it's pressure or concentration, you are going to use the same unit for the rest of them. What was the unit for the rest of them? ATMs. So you are going to write ATMs. Yeah.
But the equilibrium constant just has, it has units, but they're just too like.
The equilibrium constant does not have units.
Doesn't have units.
Huh? You put numbers with units inside.
Like they don't include the units because they just put like too crazy.
Yeah. Yeah.
But it doesn't have units.
It doesn't have units. The
No.
numbers you put inside have units. The numbers you put inside have units.
Yeah.
We omit the unit. Everybody agreed in omitting
You're
the
a little
unit
bit on reality.
because it doesn't have a lot of meaning. Now, the numbers inside do have units. Right? If you calculate the units for it, you'll be the first one in the world to do it. What happened? What about one? No units, okay? Okay, my friends. What else? Let's do another one.
I would love to see your reaction jumping out of the plane. I would pay to see it. I would pay to see it.
Guys, what's the conversation, guys? You want to go skydiving?
Can you imagine her reaction jumping out of a plane?
I would love to see that one.
Yeah, me too. That's what I'm
Actually,
saying.
I don't want to imagine her jumping out of the plane. I want to see her face before she jumps.
Yeah, like I can't even.
Without a parachute, I will put her, like, handcuff her very close to the door of this airplane. And I would throw her outside so she stays hanging around from the All right.
This is me
So the
going
equilibrium
crazy.
constant is 51.
Let's put a 2 on the each.
What happened?
Oh, 2 on the each.
Number 51, that's weird.
The equilibrium constant is 51. Why is that weird?
I don't know, it's usually like the really tiny numbers.
Use the very tiny numbers, huh? Okay, so let's say a flask
It's made of glass.
was charged with 59.19 ATMs of H2, 118.4 ATMs of I2, calculate the equilibrium concentrations for H2, I2, and HI. I want you to set up the problem as much as you can.
Mechanical school. When you're doing ice charts, you need to put the stoichiometric coefficients into the x-axis, right?
What happened?
Yeah.
When you do the ice chart, when you do like plus x, minus x and all that.
When you do like
put
plus
that-
2x.
Like for instance, for HI, would it be 2x instead of just x?
Yeah.
Which we get out of World War III, where we break up to more
But right here you can put 2.
Huh? What happened? I feel like it. Guys, I want you to set up the problem. I don't want you to complete the problem. So question here is, when you say a flask was charged, is that initial information or is that equilibrium information? Initial information. So I have initial information. What am I asking for? Equilibrium information, and you are given the equilibrium constant. What does this mean? I have to build an ice chart. Is that clear? Initial information, I ask for equilibrium, give you equilibrium constant. An ice chart has to be built. I want you to get to the end of this ice chart. We are not going to complete it. So
you have the initial, the change, and the...
yes, I have initial, change, and equilibrium, yes?
Mm-hmm.
How much H2 did I have initially?
It tells you right there.
59.19, yes?
Mm-hmm. Then
And how much I2 did I have initially?
118.1.
118.4. This is in ATMs, yes?
Yeah.
How much HI did I have initially?
Zero.
It doesn't say anything anywhere. Then the change for this for this H2 will be
Negative X.
minus X. And this change here will be
Minus X again.
minus X as well. Will be the same change. And this will be
Plus
plus
2x.
2x. Very nice. It is 2x because of this coefficient here. It is positive because it is a product.
Yep.
Reactants get a negative, products get a positive. It does not matter if the reaction goes forward or reverse. This is the way it is.
So then you have 50.
So I write this plus this down here.
Minus X.
Okay?
Mm-hmm.
No, it is not this minus this, yes? It is this plus this, but that happens to be a minus, so it ends up being a minus. You do not subtract this minus this, yes? And then this is 118 minus X, and this is 2X.
You gotta make that equal to the Q and Q, right?
What is the equilibrium expression for this?
51.
The pressure of HI raised to the second power, divided by the pressure of H2, divided by the pressure of I2. Yes or no? Very good. Now, what am I looking for? I built the ice chart without knowing anything else, yes?
Mm-hmm.
Did I build the ice chart? I built it. And then I did this without knowing anything, and now I find out what is it that I'm looking for. I did this like a robot. So, am I looking for the equilibrium constant? Hello?
Nope.
No, you have the equilibrium constant. I am looking for these pressures, yes? I am looking for these pressures at equilibrium. And I have, these are the pressures that I have. So I have to plug in those and solve for X. Okay? So, the equilibrium constant will be the pressure of HI raised to the second power. What's the pressure of HI? 2x. So this is 2x to the second power. What's 2x to the second power? 2x squared?
4x squared.
4x squared, yes? Divided by 59.19 minus x. And then 118.4 minus x. And this is equal to 51. I'm going to erase this here, okay? And I'm going to write in here 51. What is it that we're looking for? We're looking for x. We want to find x, so we can do what to x? Plug it in here, yes?
Yep.
Now, we got to solve for x, but how does this look like?
Ugly.
I don't know. It looks like some of you are going to have a problem with this, okay? Because you barely passed math. This x times this x is going to give you what? X squared. This x times that number is gonna give you a number x. That number times this is gonna give you another number x, and this number times this number is going to give you a number. And then there is an x to the second power on the top. This is the equation, this is called a quadratic equation. Okay? Do you know how to do the quadratic equation the way you told me last week? Because you told me, yeah, we can do the quadratic equation. Do it. You have 1 minute to do it. I'm not going to do the problem. I just want to see how many of you know it. If you don't know it, I'm still not going to do it. You're going to do it for homework.
I got it.
You got it? That's good, man. What you get?
Well, let's do it again.
You got it wrong.
But I got it off by a little bit, 50
Okay,
for,
right.
1.19 for H2, and then 60.35 to one.
How much? Say it again.
1.09 for H2.
No. Tell me what the x is.
I just, no, I forgot, yeah, I forgot to subtract by 4. So I got actually 60. So I messed up because I didn't subtract by 4.
It's close to that.
Doing the quadratic on this is gonna be a pain.
Guys, I'm waiting for you guys to do the quadratic, okay? You are doing it, and I am counting the time it's taking you. Ms. Rodriguez, how long would it take you? 2 days?
Looking for a quadratic.
What was the indicator that we were gonna use in ice chart here?
You were given initial information, you were asked for equilibrium information, and you have the equilibrium constant. You have 2 out of the 3.
Okay.
Okay, guys, you did it? Tell me what the values of x's are. 50.
No.
130. Don't tell me you Googled something and it calculated it for you. It's an app? Wow. That's good.
They have some apps that do everything, calculus and everything. It's crazy.
But you can't use the app on the test, okay?
Yeah, we can.
Yeah, you can? What? Let me catch you with the cell phone on the test so you can see it. I'm gonna call your parents and your sister and everybody else. Okay, guys. So, how many of you... Okay, I'm gonna tell you. One of the x's, because you get 2 of them, yes? One of the x's is 137, yes? and the other x, let's see where it is. 137.6, and the other x is 55.3. Yes?
Yes.
Who got those numbers? Raise your hand.
1 second.
If you got the numbers, I'm not gonna ask you anything, I just wanna know, for me to sleep at night, how many of you can do this calculation? Raise your hand if you calculated this yourself.
Yeah, like I know I set it up.
You haven't finished it yet. Okay, but you took too long, okay? That means your test grade is going to be lower because you can't finish a test, right? So here's what we're gonna do with this, okay? One of these two, what I need you to know, you are going to practice doing this quadratic equation by yourself. Because this is not part of my class. I don't know the quadratic equation. What is it? Like,
Negative b plus or minus the square root of
Square root of b squared minus 4ac over 2a.
that's a lot of words. So, 137, yes, is one of them, and the other one is 55. One of these two answers does not have a physical meaning. Which of them does not make sense?
55?
How do you know 137 does not make sense? Because you are going to plug them in here, yes? And if you subtract 59.19 minus 137, you get a negative pressure. A negative pressure means what? That it doesn't exist? That it goes in the negative direction? I don't know what that means, okay? We either have a pressure of something or we don't have a pressure of it,
Get stuck into another dimension.
okay? So 137 does not make sense here. The value is 55, yes? So you are going to use those numbers and you're going to plug them in here and you're going to get, so you're going to plug in 55. X is 55. 55.3. So if it is 55.3, then 59.19 minus 55.3, tell me how much this is. And 118.4 minus 55.3, and 2 times 55.3. So I'm going to tell you. This is 3.9 units are ATMs. This is 63.1 ATMs. And this is 110.6 ATMs. Those are the equilibrium numbers for H2, I2, and HI.
But you were saying about, you were talking about concentrations before, like in the problem. And here we were only dealing with
These are pressures, yes? These are pressures. They're pressures. This is pressure.
Mm-hmm.
Pressures, look.
Mm-hmm.
They're ATMs. And they're still pressures.
But why did you say
When I
concentration?
say what?
It said concentration something. I feel like the
Oh, it said concentrations?
Yeah.
Okay, whatever. Change it and put pressures now.
Okay.
So, let's do another problem, right? You want another one?
Yeah.
Sure.
A 2.00 liter flask is filled with 0.200 moles of HI. 7 back there. What is it called? What do you think, guys? You try to do the problem, but hurry up, okay? We don't have all day. You do have all day to talk. Did your parents ever tell you to shut up?
No.
No?
Just talk as much as you want.
Right. Yeah, no wonder you should have been stopped a long time ago. Guys, tell me, what is it that is given here? What do we do?
Build an ice chart.
How do you know you have to build an ice chart?
This flask is filled.
Okay, flask is filled, that means that this concentration is what? Initial, right? And then what does it say after that?
The equilibrium concentration.
The equilibrium concentration is another number. So you have an equilibrium concentration and then you have an initial concentration. And you're asked for the equilibrium constant. So this is an ice chart. Most of the time, yeah, the temperature is given to you for when the reaction was conducted. But you don't use the temperature.
So I'm assuming that the difference between the two numbers is the x.
I don't know. Build the ice chart. Don't ask questions so you mess it up for other people. Okay, everybody's trying to do the ice chart, and if you have the questions, when it's time for the question, we will talk about them. You can talk to each other, of course, but not out loud. Guys, at what time is this class over? 9:40.
We have 20 minutes. Well, 25-ish.
I have to go before. I got a stomach ache. Just kidding.
The thing is, what they give you is the moles, and they give you a formula to use it to get the
No, but he gives us molarity.
It's a question. It gives you moles, it gives you liters, you have to find molarity.
But he gives you a concentration in molarity.
I don't know. Look at the proper mole.
Because the number of moles of each
And you divide by
and then it tells you there's 2 liters in the flask.
Can't wait to go skydiving on a lightning storm.
Yeah, I see what you mean.
No, not this weekend. Can't this weekend.
Next week.
Maybe next weekend. We'll see.
Oh, that's right, this weekend's 4th of July.
I know, but
Yes,
it gives
but
us
that's
a
not why I
concentration in
can't go.
molarity. I don't see why you need to.
I'm busy like the
The
devil.
concentration, you have to find that it's
Okay.
0.2 divided by 2.
Guys, what the problem is? Huh?
The problem is we're done.
We have to build ice chart. How do you know you have to build an ice chart? Now, I have told you already many times that how much energy are you gonna spend memorizing the ice charts now? Or learning ice charts? Learning ice charts. A lot.
All of
Okay? All of it until you learn the ice charts. If not, you are going to miss so many problems on the test. You're not gonna be able to pass this course. Okay? We're gonna plug in here initial information. What's initial information on this?
No, it's a trap. Because they give you moles and they give you liters, and you have to find molarity.
What do you mean a trap? A trap? Like I want to catch you or something? To eat you or cook you or something? What do you mean I'm trapping you? I'm not trapping you.
I don't know, you're into.
So, I need here, this is concentration, yes? So I should have this in concentration. It gives you moles, yes? And it gives you liters. So the trap is apparently, I am thinking, I don't know what you're thinking, but maybe you think a trap will be that just write this number? Or do you just write that number? So you divide the moles by the liters, yes? And this gives you molarity. What's a molarity here? Huh?
I got it. I got it.
0.1 molarity. Let's say 0.136 figs, yes? So 0. Okay, done. Yes or no, my friends?
Yes.
What is the concentration of H2 at the beginning? 0. Because I never said a word about it. What's the concentration of I2 at the beginning? 0. Then there is a change. For HI, it will be minus 2x. Very good. And this will be plus x, and this will be plus x. And I'm going to write this plus this down here. 0.100 minus 2x. You agree? This is x, and that's x. And you're done with the ice chart. I do not know how some of you can't do this. It's upsetting. What happened?
So we don't calculate for K and Q?
Yeah, we are, but we finished the ice chart, didn't we not?
What do you want us to do with the given concentration? That's what.
Okay, that's where we are now. So, what am I looking for?
Okay, I think
What am I looking for? Look here. The
Yeah.
equilibrium constant.
You need that to solve for it.
Yeah.
Yeah.
Guys, did I do the ice chart without caring or without even looking at what I had to do for the rest of it? Yes. I find out I have to do an ice chart and then I just did. Okay, that's it. The equilibrium constant expression for this is products divided by reactants, yes? Because I'm giving you concentration, you're going to calculate this KEQ in concentration. By the way, the KEQ in concentration is called KC. And KP is pressure, yes? There is a way of going from one to the other. I'll think about teaching it to you. So, this is H2, concentration of H2, multiplied by concentration of I2, divided by concentration of HI to the second power.
Yeah.
Yes or no? And I asked myself once again, because I have an attention deficit, okay? Hyperactivity disorder as well, for which I take Ritalin mixed with alcohol. Just kidding. That doesn't do anything to it. Anyway, so here is the equilibrium constant is what I'm looking for. I have to plug in what type of numbers in there?
Wait,
I'm looking for this.
You're missing a very important number.
Guys, I'm asking you a question. I'm not asking what it is. What numbers do I plug in there in order to find the equilibrium concentration? The equilibrium numbers. The equilibrium numbers are these numbers, yes or no? Okay. Do I know what x is? No, I have to find x. That means I must have given you some number at equilibrium that allows you to calculate that x. Yes or no? So that concentration is the concentration of what at equilibrium? HI, yes? Here's HI. That whole thing is equal to that number. Yes or no? This thing, 0.100 minus x, is equal to whatever I give you. Just as if this were equal to whatever I give you, that is equal to this. Let's not write the m, okay? Let's just calculate x as it is. Yes or no?
Yeah.
What are you doing here?
You solve for x.
You're solving for x. Why do you need x?
Because numbers.
So you can, see,
You can do the rest.
I do not possess enough mathematical skills in the language to describe to you to find x there. Like, I don't know how to do it. So what's x equal to?
0.011.
So let's say that we're solving for this, yes? How do you want to do it? 0.100 minus 0.078?
Equals to x.
That's how? Okay, we divide by 2 there. We divide by 2 here, yes? So x is equal to how much?
0.011.
Point?
0.11.
0.011? Okay, very good. So this x is 0.011. This x is? What's this x? Do I have to plug it in here?
No.
I mean, there's no, you already have.
I mean, you could, but you already have this number. This number is here, okay?
Yeah.
0.78. So we're just gonna plug those numbers in into the equilibrium constant. It is 0.011 for H2, yes? And for HI is 0.011. Some people might say this is 0.011 squared. You can say whatever you want. I don't like it that way. HI is how much? 0.078. Oh, squared? That's right. Because there's a 2 there. Kind of missed that one. What's that equal to?
I get 1.99 times 10 to the second. To the negative second. Oh, I guess you could say it that way. Number 360.
0.78 has 2.
No.
Right? And 0.011 has 2 sig figs too.
You're right.
Doesn't matter, okay? This is not a significant figure question, class. Mr. Navarrete, what do you think? You don't, right? You just react?
I just react.
Guys, did you sign the attendance?
Oh, I wish.
I think we signed up for like 4 days.
It sounded maybe like a month ago.
So what are we gonna do? We could go home, but you haven't signed the attendance, so we gotta stay.
No.
Or is it?
When are we gonna make beer now?
When are we gonna make beer?
Yeah.
Close that.